Hello and welcome to In the Lab. Now today we have something a little bit different. It's all about destruction. Or to be more specific, it's about this. How long does it take to dissolve completely a jawbreaker or gobstopper? I suspect it might be a little bit more difficult than we think at the outset, but let's find out. Now this is a jawbreaker. It's pretty hard, but we can break it down if we use the right chemical. And this is the right chemical. At least, I hope it is. 5 molar hydrochloric acid. If we look at the hazard symbol, that means that it is irritant, but not quite corrosive. Maybe if we take this, and we take that, and we put them together, then this might dissolve because of the chemical reaction. But will it work? Well, let's take the acid and pour all of it into the beaker. I think we're going to need more than that. And now we're ready to put the jawbreaker into the acid. Now, this might be a long process, or it might be quite a quick one. Well, as you can see, it is almost completely disappeared in its own sludge there. It's about an hour in at the moment, but I wonder what would happen if we stuck in a stirring rod and gave it a little mix. Well, we've left it for quite a while, but I think we need to have a look at what's going on. Okay, let's see if there's anything still in there. Yep, there is definitely something, but we'll only see just what it looks like if we lose all this water and sludge. Aha! So we do still have a jawbreaker left. Now what you're not getting from this video is the smell that's coming from the sink. Now the reaction between the jawbreaker and the hydrochloric acid has produced a bit of a stink. It's almost a little bit sulphury. Now let's give the jawbreaker a bit of a wash just to get rid of any excess acid, and then I might be able to touch it with my skin again. We'll wait until tomorrow and add it to some even stronger chemical. Let's see if we can really disintegrate this even faster than we did today. Well, here we are on day 2 of dissolving the jawbreaker. Now, as you saw, we could use 5 molar hydrochloric acid, but it would take a long time. We'd have to keep refreshing it. And as you saw from the previous clips, well, it's not the most interesting. But it might be if we use this. Hydrochloric acid, 35%. Now, as you can see, it's not just irritant, but it is corrosive as well. That's because it's over 11 molar compared to the 5 molar we used yesterday. But if we're going to do this, we have to use a working fume cupboard and special gloves because this is nasty stuff. So here goes. So the fume cupboard is on. Let's use the acid. Now, when we're using concentrated acid like this, of course, we do have to be extremely careful with it. And we may even see a few fumes coming off the top. That's why we use a fume cupboard. Fortunately, at the moment, because the bottle hasn't been shook up a lot, we're not actually seeing many fumes, but we might do once we see this acid poured into this beaker. Well, as you can see, we have got quite a nice effect that's happened here. We've lost a lot of mass. It's dissolved into the acid, although not completely because it's still in there. If we left it for long enough, well, maybe some of it would diffuse up, maybe some of the acid would diffuse down, and over time, of course, we'd see it disperse equally. But for now, we'll get rid of all of the acid and the sludge around it. We'll see what's left, and we'll start again another day with maybe something even stronger. Well, here we are again, and it's day 3, and here is our Jawbreaker, or Gobstopper to call it that. Now, it does look a little bit like the planet Mars, especially if you held it like this. Well, you can see I've got the green gloves on again, which does mean that we're going to use something quite strong today, and quite concentrated as well, because there are strong and weak acids, and there are dilute and concentrated acids. Now, this is a strong concentrated acid. It's sulfuric acid. It's in this brown bottle, and as you can see, it's got that little pictogram there showing that it's very corrosive indeed. The hydrochloric was 11 molar, this is 18 molar. So we might see a slightly faster decomposition or dissolving of the Jawbreaker. Well, let's have a look. And of course, we're in a fume cupboard because this does release some nasty fumes from the top. So let's get that going. It's quite gloopy, almost like syrup. So let's see what happens now. Well, for the first time, it's actually floating in the liquid because the density of the sulfuric acid appears to be greater than the Jawbreaker, which we didn't have with the previous acids. Well, as you can see, the concentrated sulfuric acid has done a little bit of a job there. It's got a kind of nasty, weirdy colour on the bottom, and on the top it's just a little bit more dissolved. Well, I think we're going to have to try something else to finish it off, and that would be increasing surface area. Because as we all know, if you increase surface area, there's more surface for the acid to react with, therefore the reaction will be faster. Now, to get rid of the excess sulfuric acid in here, I'm going to have to pour it into water to dilute it. But you may or may not know that sulfuric acid, when it's diluted, it's an exothermic process. That means it releases a lot of heat. So if I'm pouring this in here, although a lot of it has reacted with the Jawbreaker, some of it hasn't reacted yet. And so if I pour it in here, it's just concentrated sulfuric acid, and I have to pour it very slowly into the water. If I pour it too fast, it actually releases so much water, or so much heat, it boils the water, and if there's that much heat in one go, it can crack this glass, and the hot boiling water and acid would go all over the place, including the camera, and we don't want that. So I do have to pour it very slowly, and I can tell you that the bottom of this glass is very hot indeed. So I'm going to pick this up, pour it away, and repeat the process, making sure this is diluted enough to go down the sink. So it's time to increase the surface area of the Jawbreaker, and here it is. How are we going to do it? Well, I'm not normally a violent person, but I can be if I need to be. So here we are on the floor, ready to deal with this. Of course, I'm going to wrap it in something first, and cling film is a perfect item to use. We'll see if it works. Jawbreakers really are very tough indeed. So we've taken the cling film off the pieces of Jawbreaker. Here we are. Well, I could keep going with churning, but I've been doing that for quite a while, and I think we've got plenty of powder in there and just a few of the larger bits left. Well, it's time for the final bit of acid. Now I'm just going to tip in all the bits that we produced a little bit earlier on. It's been a right slog, hasn't it, to get rid of this Jawbreaker. We've used various different acids at several different concentrations and then mashed it up to increase the surface area. Now, this better work, because destroying this thing has been quite tough for us, hasn't it? So we can take back to the hydrochloric acid 35%, or roughly 11 molar. Well, we have done a good job so far. It's looking like some of those pieces have dissolved, but we could do with speeding it up a little bit more. Now, the only way to speed it up now, I think, is to constantly mix the solution with the bits in so that the acid reaches all the different areas or sides of the bits that we have. In other words, increase the surface area or keep it high continually by mixing it all up. And what we can do to achieve that is to use a magnetic stirrer. Now, this is a very clever device. I'll show you what happens if we turn it on. It's battery powered, so it'll work like this. As I turn it on, I can show you I can even tip it and it will still work. The magnetic stirrer is spinning round because the magnet underneath is spinning incredibly quickly. I can drop the magnetic stirrer inside, turn it on again, and our magnetic stirrer is already starting to mix up the solution. You might be able to see some of the bits rising and falling as it goes round. I'll just try and centre it just to make sure. If we turn it up, it will spin faster and more of the pieces get caught up in the movement, which is exactly what we want to happen. So we will leave this little whirlpool going for a bit longer on time lapse and we'll see exactly what will happen. I think you know. And at last, the Jawbreaker will be at an end. Well, as you can see, it does look as though we have finally gotten rid of all the bits. We have a fairly nice solution, which is a lovely pinky colour. And if we turn it off and pour it into another beaker, we can see just how well we've done. Let's have a look in there. Look at that, the bits have disappeared. We have done it. And that was the magnetic stirrer clanking there. We have done it, we have managed to dissolve, and it's taken us a long time to do it, but we've dissolved a Jawbreaker. Whew. And I'm not going to do that again. Well, there you go. That's what it takes to dissolve or completely destroy a Jawbreaker, using acid and brute force, as well as a magnetic stirrer. Well, as you noticed, it did seem to dissolve quite a lot at the start when we used the weaker, or rather the more dilute acid. As we increased the strength and as we increased the concentration, well, we would have expected it to be a lot faster. I think the outer layers dissolve quicker so that when you first put it in, you get a lot of taste, and then as you keep going, it gets harder and harder to get right the way down to the centre. Maybe that's what it was. But we managed it. We did get all the way through. And just imagine how many hours it would take just using your saliva if it took us all the time it did take using force, stirring, and very strong acid. What a Jawbreaker that was. Anyway, I'll see you next time on In the Lab. Bye for now.
Like and subscribe! In the lab.